will be looking at the regular payment formula. So the formula is a nice looking one. We got the amount is equal to the regular payments, and then you're going to have the same term that we had for our compound formula, 1 plus your rate over the number of periods, and then the number of periods times the number of year minus 1 over all this over your rate of a number of periods. So let's identify each value. So $300 investments every 3 months. So this is your regular payment every 3 months. So it's 4 times a year. And invested rate, this is your rate. So this is your N and T. So I've got every value here. So it's going to be A equals 300 multiplied by 1 plus your rate is 8% over 4, so 2%. And then 4 times 16. 4 times 16 is 40, and then 4 times 6 is 24, so 64 minus 1 over your rate divided by number of periods. This term again we talked about was 2%. So that means your amount, I'll carry over here, I'll just clean this up a little bit, is 300, and then we'll calculate this term here minus 1 on the calculator. So that would end up being 1 and 2/10, right? Because then exponent 64 equal to that. Oh, not plus, minus 1. So 2.55 if you wish. 0.5, let's see, over 200. So let's just multiply that by 300 and then divide by 200. So that would get a final value of $38,272 and roughly 40 cents. Nice little amount. And now here I have to find the monthly payments. So same idea, but the unknown would be the regular payments. So 10 years, that's your time. That's your rate. Monthly, so N is 12. And this is my amount at the end is 1,300,000. Wow, that's a lot of money. Let's see how much we have to pay, but don't forget it's compounded monthly. It's pretty impressive to get that nowadays, but say you got a good deal. So let's set that up. So the amount, 1,300,000, is equal to the regular payment, which was what we're looking for, over, and then 1, your same term here, your rate is 14 hundredths over 12. All that is exponents 10 times 12, so 120, minus 1 over this same term here. So let's calculate this expression here and this expression here, same as we did last time. So the amount is just still 1,300,000 is equal to, this will end up being the coefficient for R. So let's do that in the calculator. Start off by this expression here, 14 hundredths divided by 12, number of periods, plus 1. And that's exponent 120 equals minus 1. So that's my coefficient for P, for the regular payment. So 3.0225 regular payments over 1400s divided by 12. So this expression here, 116 repeated. Okay, now to solve this, you'll have to divide these two numbers, or you could do that times that divided by that, or you could divide these and then multiply by that. But I already have this number here, so I'll just multiply these two and then divide by that. So let's do that. So I'm going to multiply by 1,300,000, and then I'm going to divide by this expression here, my coefficient, and that's my monthly payments I have to pay out every month. So my regular payments, if I pay out roughly $5,000 every month for 10 years at an interest rate of 14% compounded monthly, I'll end up with $1,300,000. There you go. That's how payment works.